Hello everyone, this is DA from my academy. This video is about a very important relation of second countable spaces. The relation is if X and tau is a second countable topological space, then X and tau is also separable topological space. So now we will prove this relation of second countability as a separable space. Now the first step is to recall the definition of the separable space. So a topological space X and tau is a separable space if the set X has a countable dense set or dense subset. So what we need from the second countable space is a subset of X that is both countable and dense at the same time. And recalling the definition of the second countable space, so X and tau is second countable space if X and tau has a countable basis of tau. So we have countable basis for that topology tau, and we need a subset of X that is countable and dense at the same time. So let's start this proof. So by definition, let B is the countable base for that topology tau that is equal to B1, B2, so on to Bn, and also so forth and so on. We know that every open set can be expressed as the union of sets in some subcollection. That is, every open set can be written as a union of some elements of the basis or some collections. Let's say B belongs to a subcollection B dash, where B dash is a subset of the basis B. This is what we use here, the definition of basis. So every open set can be written as the union of sets in some subcollection, where B prime is the subset of basis B that is countable, and B are the elements of B dash as well as from B. So we have recalled also the definition of the basis here. Now let's suppose an assumption that the basis B does not contain the empty set. If it has empty set, then we are not interested in that. Empty set does not belong to the basis. Therefore, from every element of the set, this basis, we take X from every element and form another set A. That is, the set A contain x1, x2, so on to xn, where every x belongs to Bn, elements of this, for all n belongs to n. As basis is countable by definition, so this set is also countable. So this set A, that is a subset of X, is countable because it contains the element of this basis, and basis in the topology is formed for this tau within X and tau, the topological space. So that is why this set A is a subset of X, and from the countability of this basis we can extract the countability of this set A. So the first requirement of the separable space is fulfilled now. Now moving toward that A is also a dense set in order to be the second countable space or separable space. Now if we counter all of the open sets other than the empty set, that is, if U that is a part of the topology other than empty set, topology contains all of the open sets and empty set is also one of the open sets, so we have to deal with the open sets other than empty set. So then we have intersection of A and all of the open sets other than the empty set is not empty, because in set A we have elements from each set in basis, and by definition U is equal to that. We have recalled the definition of the basis can be written as the union of sum of the elements of B prime, and this is B. So this is the definition of basis. So this is what the definition of the dense set is, because every open set other than the empty set, and if we take the intersection of that subset of X with all of the open sets, and the answer is not an empty set, then the set is the dense set. Here U is again clearly generalized as the members from the basis, because in the Stokes we only have that countable basis. So that's why this was again used in order to memorize and mention that we are not taking any elements other than from this. We're using only the elements of basis to prove that they've taken the subset of X A that is countable and dense. So this is the definition of the dense set. This implies that A, that is a subset of X, is countable and is also dense set. So combining all, we can get X and tau, that is a topologically second countable space, is also separable topological space. So this is for now. If you're looking for more such videos, then you can subscribe this channel in order to watch more upcoming videos. We will meet in the next video. Till then, take care. Goodbye.